Hey everyone, with you, Carl Carpenter's with you right now, consultant for Arrakis Consulting. Um, today we're gonna talk about the network layer of the OSI model. Now, initially I was thinking about just adding every single thing possible into the network layer, and then I remembered some of the horror stories that I experienced personally teaching the OSI model and having conversations about it. So I think in this case, I'm just going to kind of make it a short video, and I'll make other videos that specifically talk about specific other areas of the network layer instead of trying to cram it all into one video at a time. Honestly, and that's for people so it's just not overwhelming. That's because the OSI model is not necessarily the funnest thing to talk about. So with that, let's dig right into it. Let's get going on this. So the OSI model, the third layer from the bottom, is called the network layer. And in my opinion, it's one of the most interesting layers that there is. I certainly love the transport layer as well. If you can ever love anything doing with the OSI model, that is. Generally, I find the OSI model a fairly boring subject, but it is one of those things that you do have to know if you're going to do anything in IT. Network engineering or cybersecurity. It's kind of important to completely understand it. So we have the network layer at the it's the third layer from the bottom. Data here is called a packet. So a packet is a collection of frames. So if you don't know what a frame is, be sure and watch the data link layer video. And if you don't know what a bit is, you might want to watch the physical layer video and the short video we made in relation to taking binary, which are bits, ones and zeros, and converting them into decimal, which kind of deals into IP addressing and things like that, decimal. Anyway, so data at the network layer is called a packet again, and that's a collection of frames. The network layer also makes routing decisions through route discovery or route selection. Although if you don't have a routing protocol that uses route discovery, then you can also do it the manual way and have static routes. Generally, don't recommend that unless you absolutely have to. One of the good things about static routes is there's no real routing traffic. The only issue with that is networks are so fast now that who cares? And the whole concept of routing decisions is that packets that need to get to a destination that's fairly far away, the routing decision, the router, the layer 3 device, makes the decision on how to forward that packet to the destination. It's also important to understand that routing decisions will be based on a weight, like which one costs more, costs less, which one takes longer to get there, as opposed to a faster route, things like that. So these would be routing decisions. And then before I move on, when I say a layer 3 device, I'm talking about devices found at the network layer. So you will see cases where you'll see cases like a layer 2 switch versus a layer 3 switch. To me, I view a layer 3 switch as a router with just a whole bunch of ports on it, as opposed to a layer 2 switch, which is just a switch. Doesn't make routing decisions. It'll make switching decisions, but not routing decisions. So after a route is decided upon by the layer 3 device, then the packet is sent on its merry little way out whatever port it's supposed to go to get to the destination. So that's called packet switching. And again, we're talking packets, so this is a layer 3 activity. And the network layer also, much like all the other OSI layers, they interact with the layer directly below it, which is the data link layer, and directly above it, which is the transport layer. So in this case, the network layer interacts with the data link layer to translate IP addresses into MAC addresses as the data goes farther down the OSI model. While you can have connectivity by IP addressing, all actual connectivity is only through MAC addresses, but there is a translation involved, and that's what the network layer and the data link layer do together. So, for example, you probably know how to get to 192.168.1.10. But would you know the MAC address for 192.168.1.10, and could you memorize that? So probably not. So that's why IP addresses are there to help human beings understand a little bit better on communication. It's the same thing with DNS names. Kind of getting off the subject a little bit, but the only reason we have DNS names is really for human beings, so we can type in www.google.com as opposed to whatever IP address Google has at the time that it has it. All right, so also in the network layer, we have a basic form of error control. So I did talk about in the data link layer that there's some CRC checks, and I said that would be the first occurrence of CRC checks. Well, there's other error control that can happen. So we have a basic form of error control at the network layer also. Now, super important to understand that IP addresses and network addresses are found at the network layer. In relation to what an IP address is, I assume everybody knows that, but do you know what a network address is? If you don't, then I would suggest you look at our subnetting video where we talk briefly about networking addresses. And a network address in a nutshell, just to go real fast, is the address for the entire network. And it's generally and actually it's not generally, it is the lowest IP address in the subnet. So in the subnet video, I talk about 2 IP addresses that are unusable. So we talk about having like 256 possible IP addresses, but 254 usable. Well, the very bottom of the unusable, the lowest IP address in the unusable, is the network address. There's also different types of data found at the network layer. We have data packets. That's your internet traffic, your email traffic, watching Netflix or YouTube. That's your data packets. The route update packets, that would be the routers or the layer 3 devices talking to each other, saying, in order to get to Netflix, you need to go out this port on that router as opposed to this port on the other router. And that's path selection or route selection. And when we get into how routers work in greater detail, then that'll make more sense. But the 2 types of packets at the network layer are the data and route update packets. We also have hardware found at the network layer, routers, gateways, and I put in layer 3 switches just to make it easy to understand. In most cases, if you look on your if you look at your, like if you do ipconfig or ifconfig, if you're running Linux or Macintosh, you'll see an IP address, a subnet mask, and then a gateway. So that's what they're talking about here, is a gateway on how to get out of your IP network based on the size of the subnet mask. Routers are routers. Layer 3 switches are also routers, just with a whole bunch of ports. And with that, I'm going to cut this one short. Again, I didn't want to make this too in-depth, so plan on, instead of one giant long video relating to the network layer, plan on this with a whole bunch of tiny videos relating to the different areas of the network layer that might be important to you. And so to make it a little bit easier on how to understand how all this works without being overwhelmed all at once. You want to make it easy. And with that, thank you for your time. I appreciate if you guys would subscribe to the channel, check out our other videos, leave comments, things like that. If you have any suggestions for videos that you'd like me to talk about, feel free to put that in there too. And with that, I will talk to you later. See ya!